So in this lesson, 5-3 inequalities in a triangle and 7-4 midsegment. Go ahead and start with your warm-up 1 through 4. Push pause, try it, and then push play and check when you're ready. Number 1 should have gotten -2, 5. Number 2 was 8 because you're doubling the short. And then BE, the total being 15, you want to divide that by 3 to get the short and then double it to get the long. And then GC, this one being 8, you're going to cut it in half to get this short segment there. So in this one, we're going to recognize and apply properties of inequalities to the measures of angles of a triangle and to the relationship between angles and sides. So an exterior angle here always has to be greater than either of these remote interior because we know these add up to give us 1. Both of those individually would have to be less than the 1. So let's take a look at this picture here, and we're going to circle the largest. So if we're looking at 2, 10, and 16, 2, 10, and 16, which one's largest? Well, these are the two remote interior. This is the exterior, so 16 would have to be the largest. And then if we looked at 14, 11, and 4, then we're looking at this triangle here. And these are the two remote interior. 14 is the exterior, so we would circle 14 because it's the largest. 1, 8, and 10, we're looking at this one. Here's my two remote interior. Here's my exterior, so 10. So go ahead and try those last two. And hopefully you got 17 and 15. So the longest side of the triangle is opposite its largest angle. The shortest side of the triangle is always opposite the smallest angle. The largest angle is opposite the longest side. The smallest angle is opposite the shortest side. So longest side in this example here is going to be across from the largest angle. So look for the largest angle and we're going to go opposite, and so the longest side would have to be AB. The largest angle in this case is going to be angle C. The shortest side is going to be across from the shortest angle, and so that is BC. And of course, the smallest angle we can see there is angle A. So let's put some in order, knowing that we know the opposite has to correlate to the angle and sides. So if we're looking for the angles that start with the smallest here, we're going to find this shortest side and go across to find the smallest angle. So I'm going to put C. Then I'm going to go the next one up from 11.1, which would be this one right here. And so it's going to be across from angle A. And lastly, B would have to be the biggest, and it is across from the longest side. And then if we are listing our sides, we're going to go across from the angles. So the smallest or shortest, we go to the smallest angle and we go across. So AC is the shortest side. Next up, 55, across would be AB. And then 80, BC would be our longest side. Last thing we're going to talk about is the midsegment. And if we are in our midsegment, it is midsegment of a triangle connects the midpoints. Connects the midpoints. So instead of going from that midpoint all the way to the vertex like we did for centroid, we're just going directly and connecting all of those midpoints and making kind of a little triangle inside, or connecting them across here to make what's called a midsegment. And that midsegment of the triangle is parallel to that side here, and it is half the length of that CB. So if DE right here is 12, then this would be double, it would be 24. If CB was 18, then we could cut this in half and know that DE would be 9. So let's go ahead and apply that. What would be parallel to LM? Well, this one, BC. Go ahead and fill in what would be parallel to AB, what segment? The mid-segment here, MN, is hopefully what you got. Now let's fill in some pieces. AC, we know this whole right here is 14, so what is LN? Well, it's parallel, and we know that if it's the mid-segment here, it's half. So 14 divided by 2 would be 7. MN, this length here is 8. So what is AB? It is double, so 16. NC is 3, and notice it has 2 tick marks, and anything else that has 2 tick marks is going to be congruent. It's asking, though, for LM. Well, if this is 3 and this is 3, the whole is 6, and then this is half of that whole side, so it is 3. And then LN is 5, and then what equals 10? If that's half, then this side would be parallel, so AC would equal 10. It would be double that. Down here, we're going to take LM, that one, and then BC. So we need to, they're not equal, we know we need to double this, and then they would be equal. So we're going to take and double 3x plus 1, and you can either write it twice or you can take 2 times it and then set it equal to its parallel side. But we know that this is only half of that, so we need to double it or cut this in half and then set them equal. You can do it either way. So 6x plus 1 equals 10x minus 6, and then subtract your 6x. 1 equals 4x minus 6. Add your 6, 7 equals 4x, and divide. Oh, made a mistake there. Hold on. Going too fast. Who caught my mistake? It's a mistake you guys make a lot. It was distributing mistake. Whoopsie. So that should be 2. There we go. And a lot of times you're going to get pretty numbers, so if you don't, that's when you go back and look. So it should be 8 equals 4x, and then divide by 4, and there we go, x is 2, which means LM, if I plug a 2 back in, 3 times 2 plus 1, 6 plus 1 is 7. So if you want to try this next one on your own, go for it. You're going to be given NM, and that's x minus 1, and then AB is 3x minus 7. So which one? We need to double this one, and then we can set it equal to that one, the longer. So 2 times x minus 1 equals 3x minus 7, and go ahead and solve that. Don't forget to distribute to both, and then subtract your 2x, and then add your 7. And you get 5 for x, and then we need to plug it back in. 3 times 5 minus 7 is 15 minus 7, so that leaves us with 8. All right, so on this last one, go ahead and label all the parts, and then see if you can figure out what is that perimeter of your big triangle. So if this is 4, which means you have a total of 8 on this side. If this is 7, then that means this side is 14. So you're going to add 8, 12, and 14 to get your perimeter of the entire triangle, and it would be 34.